Good morning, guys. We're day 23, I think, and it is the 9th. It's my Lucy's birthday. So we have been having donuts and opening one present at a time and using those presents and playing with those presents. And then I'm a mean mom. I'm still making them do some school stuff. So I'll get a video on here for you. I want to start with the think questions that you answered yesterday and just go over those. I saw a lot of great responses using vocabulary. So question 1, what rules determine whether magnets will attract or repel each other? So you've got opposite poles attracting attracting each other. So here I know because there's a force and they attract, they pull together. There is a north and south pole. It's opposite. If I take this one and I flip it around, they do not want to stick to each other. There is a force pushing them apart. So I know these are the same poles, whether it's both north or both south. So those are kind of the rules there. The next one, 2, says, how can a magnet attract or repel another magnet even when they are not touching? So if you've got a magnet here on this board and it pushes, opposite sides, now I'll put them on the same side, and it pushes or pulls it, like I can get it close, and they're not close to each other, but I'm making it move before they touch. How does that happen? So here I want you to say something about the magnetic field. So a magnetic field will extend out and come back to it, and the magnetic force is in this area, in this region of the magnetic field. And then number 3 asks, if you bring the south pole of a magnet close to the head of an iron nail, what changes will happen to the iron particles? And the video that I posted previous to this assignment shows that in a visual display, but here's an iron nail. So when it's not connected, the iron nail's particles aren't aligned, they're just arranged randomly. But as soon as you put it within a magnetic field, the magnetic force snaps those particles into alignment. So this is a ferromagnetic item. It's made out of iron or steel, and that means that its particles will align with the magnetic field. See if I can get it to do this too. All right. So, and that's because the iron particles are like tiny magnets. So they'll line up when they're within a strong enough magnetic field. The iron particles will have their north poles attracted to the south pole of the nearby magnet. The iron nail becomes a temporary magnet, okay? And what I'm doing here is I am inducing magnetism through this. Because its particles line up, I can get other things to stick to this as well. So if I take a paper clip like this, I've induced magnetism through the nail because it's a temporary magnet. And so now that magnetic field has been extended, and this has become a temporary magnet, and so has this. And so there you have it. Okay, so today we're just going to touch on the next idea. So you know what happens to magnets when they get close to each other and their magnetic fields can overlap. They interact with each other. And the magnetic field is around a magnet. And you know from the previous unit or the previous investigation that a force is a push or a pull. So now what does that have to do with anything? Well, if you're pushing and pulling using a magnetic field, you're creating kinetic energy. So when two magnets repel each other, the force of magnetic repulsion pushes the magnets apart, like I demonstrated on here. Hold on a second. I got a kiddo asking a question. Okay, So what I was saying was when two magnets interact with each other, their magnetic fields interact, and I can push them or pull them, and that is creating kinetic energy. So here's the other end of it. When a magnetic object is in a magnetic field, the force exerted on that magnetic object has the potential to make it move. So like this point right here, right before it causes any interaction, oh, and there you see it just start to wiggle. That is potential energy. So it has the ability to make it move, and that amount, kind of like that moment before you're waiting, that's called potential energy. So we're going to have more on that probably on Monday. Tomorrow we'll do a Science Friday, and we'll look at some news articles that interest you. So today, what I'd like you to do is I'm going to post the response sheet, and I want you to answer it in the short answer section. So I'll post a question. You can answer it in the short answer section online. And then also I want you to go check out that video I posted previous to this post that talks about nanoparticles aligning to a magnetic field and how that helps cure cancer. And then at the end of that video, and also in the post, I put a link to a website. I want you to go check that out and see if there's anything there that interests you. If you want to take on a project and you need support, you just let me know what I can do, and we can work on that together. So this is the response sheet, investigation number 2, that I want to go through. It says if you put something like a piece of cardboard between a magnet and an iron nail, the magnet still holds the nail in place, even though the magnet is not touching the nail. Explain how that happens. Use the word induce in your response, but I also want you to use the other vocabulary that we've had here as well. So the activity that the response sheet is talking about can be demonstrated. So in this box I have a nail, and I've got my donut magnet. It's got a paper clip stuck to it. And so it wants you to explain, like, what the heck is going on there? I'm not touching the magnet, but I am causing kinetic energy to happen, and then I can hold it in place. It's not like I'm not holding the nail. It's just, it's just hanging there. I can also do it like the head of the nail, like it says in the response sheet. Okay, so what's happening to the particles? What forces are acting? Use your vocab and do your best. Thanks.